Hello everyone, welcome to MindSpan Education. In last video we looked at the conditional probability density function of a single random variable given an event. Now let's look at an example. Let's suppose we have this probability density function, and if you observe, this probability density function is a piecewise function, and we have given this event A, and this how this event A has been defined. So this event A occurs whenever the random variable takes the value in between these values, that is a plus b divided by 2 and less than b. In first part we have to find the conditional PDF of this random variable x given this event A, and in part B we have to find the conditional expectation of this random variable x given this event A. Let's first try to find this first part. So initially the random variable x was taking the value from this range, that is from A to D. Now we have given this condition that random variable takes the value in between these two values. So where this a plus b divided by 2, so this will be the midpoint of these two, right, a and b. So here the point that will be a plus b divided by 2. So initially our universe where the random variable was taking the value in between these range. Now with this given condition, our universe has got shrink, and this is what we call as a conditional universe. Now random variable can take the value between these two values. So we have given this condition, and now we are interested in finding the conditional probability. So within this universe there would be, so whatever the probability we are interested in after imposing this condition or after giving this condition, if that is out of this range, then the probability of that event would be 0, and this is what we have seen in our last video, right? So outside of this universe all the conditional probabilities will be 0. Within this conditional universe, what will be the probability? So it will be, again, the PDF would be same, but it would be scaled by some number, right? So within this range, in the unconditional probabilities or the PDFs are constant, so it will be again constant, but we don't know that how much it has been scaled, right? So basically what we are drawing is the revised probabilities or revised PDF, right? So obviously it will not retain the same shape, it will have some, it will scale itself such a way that the total conditional probability should be add up to 1, right? Because we know that the unconditional so that the conditional probabilities are also the legitimate probabilities. That means the total probabilities in in conditional universe should also be add up to 1, right? Here this conditional probability is scaled by this conditioning probability of this conditioning event, but the problem here, we cannot find the probability of this event A, right? In order to find this probability of this event A, that would be integration from this a plus b divided by 2 to b, we need to find the what will be the PDF here, right? So here the height of the PDF for all these piecewise, we do not have the info of that. So we cannot say that what will be the height between what will be the height of the PDF in between these ranges. But we have this info, or we know that the conditional probabilities or the PDFs are also a legitimate PDF. That means the area under this probability density function should also add up to 1. That means the area of this rectangle should be 1. So in order to make the area 1, what should be the height of this conditional probability density function? So the height would be, so the area has to be 1. So that means this height and this width, once we do the product or find the area, that should be 1. So it would be b minus a plus b divided by 2. So that will be a minus b divided by 2. So this height should be 2 divided by a minus b, right? Now if you multiply or find the area, so area is width into this height. So width is this, height is this, this 2 will get cancelled, this a minus b will get cancelled, and you will have the total area 1, right? So this is what the conditional PDF of this random variable x given this event a. Let's proceed further and let's try to find out what will be the conditional expectation of this random variable x given this event a. Again, the idea is same. How do we find the expectation? If it is in the conditional universe, then we are going to make use of the conditional probabilities or conditional PMF or conditional PDF. So in order to find the expectation, we are going to make use of this conditional PDF, right? Because we have to find this conditional expectation, right? So under this given event a, we have this PDF. So we are going to make use of to find the expectation of conditional expectation, right? Again, if you look at this PDF is a uniform PDF. So what will be the expectation of a uniform PDF? It would be at the midpoint. So what will be the midpoint? The midpoint will be a plus b divided by 2 plus b divided by 2. So that would be a divided by 4 plus, how much this would be? So b divided by 4 plus b divided by 2. So that would be 3 divided by 4 b. So this is what the conditional expectation given this event a, right? So you see